This is Humidifirst Mist-Free Series Ultrasonic Humidifier. It comes in sizes Mist-Free 10 and Mist-Free 20. The Mist-Free 10 does about 10 pounds of humidity per hour, or about 1.2 gallons, and the Mist-Free 20 does about 20 pounds of humidity per hour, or about 2.4 gallons per hour. After unpackaging your Mist-Free Series humidifier, simply roll it into your desired location. There are some things to think about when choosing the location of an ultrasonic humidifier. The placement of your Mist-Free Series humidifier should generally be as centralized as possible. Although humidity works on pressure principles, so the higher humidity levels will automatically seek out and balance lower humidity. Most importantly, the area in front of your discharge baffle should be open and clear of any obstructions. You may find dripping and wetness on any objects that the mist is allowed to condensate and collect on. Also note, smoke detectors are triggered by vapor such as smoke. However, ultrasonic mist vapor will also trigger a smoke detector. So ensure your smoke detector and fire alarms are clear and away from the humidifier's discharge. All of Humidifirst ultrasonic humidifiers require a plumbed water source. Generally, we recommend treated water such as reverse osmosis or deionized, although there can be specific scenarios where treated water should not be used. All of our humidifiers will ship with a 1/4-inch water line with male-female disconnect and attached Y strainer. This will allow you to quickly disconnect the water source. Note, water will not flow unless the male and female are connected, and most importantly, the debris Y strainer. This strainer will remove debris in the water line and keep it from entering your humidifier. Note, humidifier overflows are mostly caused by debris in the water line sticking in the humidifier solenoid. To utilize your Y strainer and quick disconnect water line, simply take the end of the water line from the Y strainer and plug it into the compression fitting marked water supply. Simply press it in firmly and it should hold on its own. You would then take your water source and plug it into the 1/4-inch compression fitting at the end of the Y strainer water connect. On the side of the Mist-Free Series humidifier, you will see overflow, drain, electric, water supply, and the optional water guard sensor. Let's look at them one at a time. The overflow is a 3/8 female pipe connection used to direct an overflow in the humidifier's water pan to drain. The drain should not be piped, but you may add a manual ball valve to empty the water pan for maintenance. The electric connection is a standard 120 VAC plug. Note, the Mist-Free can be powered by other voltages. Inquire about this during your order. The water supply connection is a 1/4-inch compression fitting. Simply press the 1/4-inch water line into the fitting until firmly in place. The water guard sensor is an optional overflow protection feature. It would be screwed into place at the overflow tube. We will discuss the water guard system in detail later in this video. Startup procedure. There are a few best practices for starting up a new Mist-Free Series humidifier. First, make sure the unit is unplugged and the power switch turned off until the proper time. You will want your Mist-Free stationary in its final location to start up. Do not move the unit while running, as the water sloshing side to side can damage the system's transducers. The transducers are the small, quarter-sized discs inside the humidifier's water pan. You will want to protect them for the longest lifespan and performance of your humidifier system. When starting up a new system, or restarting a system that has been shut down during the warmer season, you will need to access the Mist-Free's water pan to check for debris from construction or installation and prime the transducers with water. To do this, remove the 3 thumb screws on each side. After removing all 6 screws, you may remove the unit's fan cover. Note: there is a 3-foot cord connecting the front-mounted humidistat to the mist-freeze interface plate. Be careful not to pull or rip on this cord. After setting the fan cover aside, you will see the transformer, solenoid, interface plate, and the mist-freeze serial number. There will also be 3 black ball nuts on the stainless steel vertical. Remove these to remove the chute. Note: when removing the chute, pull straight up on it until it is clear of the water pan. Be mindful of any wind gusts or air movement that could knock over your chute or fan cover and damage it. You will now have access to the unit's water pan and transducers. Let's take a closer look at the transducers now. You can now see the water pan and transducers. First, make sure the water pan is clean and clear of any debris from construction or unpackaging. Next, you're going to want to prime the transducers with a small amount of water. The transducers can never operate dry, so covering them with about an inch of water is a best practice. You may now reassemble the unit. When replacing the chute, be sure to come straight down into the water pan. Forcing the chute at an angle can catch and tear the sealing tape on the back side of the stainless steel vertical. Once your chute is in place, you can retighten your 3 black ball nuts to hold the chute in place. It is also a good idea to check all your electrical connections are tight and secure, as sometimes they can become loose in transportation, unpackaging, or installation. When replacing the fan cover, be sure the humidistat cable remains inside the unit and is not pinched between the fan cover and the vertical. You can now retighten your 6 black thumb screws to hold the fan cover in place. At this time, your 1/4-inch water line should be reattached, and make sure you have proper water pressure at your mist-free humidifier. The mist-freeze power switch is located on the front bottom of the unit and may be switched on at this time. After performing the proper startup procedure and turning your unit on, the mist-free will fill itself up with the proper amount of water. The first time you turn on your mist-free unit, you should hear water running through the solenoid into the water pan. The standard mist-free unit comes with a front-mounted digital humidistat. Note there are also other control options such as a remote humidistat wired back to the unit, dry contact points you can activate and deactivate yourself, and BMS and proportional control through our HC301 microprocessor. Let's take a closer look at the standard digital humidistat now. The standard mist-free series ultrasonic humidifier comes with a front-mounted digital humidistat. This will show you the relative humidity in your space and your current desired relative humidity set point. To turn the humidistat on, simply press the power button. The large number on top is the current relative humidity in your space. The smaller number in the middle is your current set point. A new mist-free will ship with a set point of 10%. Note the decimal, as this can be mistaken for a set point of 100% relative humidity. To adjust the set point, simply press the up and down arrow to your desired level. The standard digital humidistat has a margin of plus or minus 5%. A plus or minus 2% version is also available. To activate the mist-free humidifier, simply adjust the set point to your desired level above the current relative humidity. In this case, we have a relative humidity of 67%, and we will adjust the set point to 85%. Note, there is a slight delay until the humidifier activates. Motion bars will appear on the side to indicate the humidifier is running. Also note, the humidifier must be filled with the proper amount of water and have a proper water source plugged into the water supply connection in order to create humidity.
Your mist-free unit should now be ready for use. As long as the unit is supplied with the proper amount of water and the humidistat is calling for humidity, you will hear the fans running while the unit produces ultrasonic mist. The mist-free will automatically refill its own water supply and cycle on and off to maintain your desired set point.
The water guard is an optional overflow detection system used to protect your mist-free humidifier and the area around it during an overflow. A new mist-free will have the water guard sensor inside the fan cover to protect it during shipping. To install, remove the fan cover as discussed earlier. And locate the water guard sensor tube. Note, there will be a small bag of rock salt inside the tube during shipping. This is inserted in the tube to create conductivity for treated water. Insert the salt into the tube and screw onto the overflow pipe connection on the side of the mist-free. Note, the prongs must be in the up position facing downward to work properly. If the tube is installed in the down position, condensation and water can pool on the sensor and give you false readings. Ensure the tube is in the up position with the prongs facing down. If the water pan were to fill up with too much water, the water would enter the sensor tube and trigger the water guard. The components of the water guard detection system are also located beneath the fan cover. These would include the water guard control, the audible alarm, the dry contact points for overflow notification, and the flood guard valve, which is a secondary solenoid in the water supply used to shut down water to the system. In the event of an overflow, the sensor tube would fill with water, and there is a delay on the sensor tube in order to prevent false alarms. Once water has been in contact with the sensor tube for the proper amount of time, the water guard control will be triggered. When the water guard system is triggered, the following things occur. First, the water guard will shut down power to the unit, deactivating the fans and transducers to protect the humidifier system. It will also send out the loud audible alarm, letting you know that there is a problem. There is also a set of notification contacts marked
30 and 31.
These will close and can be remote monitored by another system for leak notification. There is also an optional secondary solenoid known as the flood guard solenoid. This would be installed in the incoming water line and is a normally open solenoid allowing water to pass through. When the water guard is triggered, it would power terminals
32, 33.
which would power the solenoid and close the water supply completely to the unit. This is important because the majority of overflows are caused by incoming debris in the water line sticking the fill solenoid and not allowing it to close. The mechanical nature of this problem is not resolved by electrically shutting down the unit. So the secondary flood guard solenoid ensures that there is no water supply to the humidifier in the event of a leak detection. By default, the fans inside the mist-free humidifier will cycle on and off with the transducers. This means the fans will turn off when there is no call for humidity. Some applications that keep high levels of humidity can find an organic growth inside their chute due to the high level of humidity. The easiest way to stop this is a simple switch which will allow the fans to run continuously whether there's a call for humidity or not. The air movement in the chute will dry it out and stop that organic growth from happening. This is a simple process that's done at the terminal block located on the interface plate. Following our wiring diagram, the wire at the bottom of number 10 is the power for the fans that cycles on and off. In order to make the fans stay on continuously, we move this wire at the bottom of number 10 to the open H block all the way to the right. This will be a constant source of power that will cause the fans to run continuously and dry the chute out. Now let's talk about some best practices and maintenance for your mist-free ultrasonic humidifier. The transducers inside the water pan that create your ultrasonic mist vapor are designed to last about 10,000 hours. That's under nominal conditions. Clean air and clean water can help them reach that nominal lifespan and even go farther. Dirty air and dirty water can severely shorten their lifespan and cause you to need them to replace them more often. The two biggest factors to quality inside the humidifier is water and air. Generally, the factory recommends treated water, an RO, reverse osmosis, or DI, deionized water source. Although there are certain applications with heavy organics in the air where treated water can harm you as much as help you. The most important things to think about when choosing an RO or DI system is that the water's treatment system can properly feed the humidifier with the right amount of water. The Mist-Free 10 is doing 10 pounds per hour, or about 1.2 gallons per hour. The Mist-Free 20 is doing 20 pounds per hour, or about 2.4 gallons per hour. An undersized water treatment system can starve the humidifier for water and not allow it to work correctly, and even in some scenarios damage the transducers because they're not allowed to operate with the proper amount of water on top of them.
The best practice for ensuring the longest lifespan out of your transducers is to keep the water pan clean and clear of any contaminants. The transducers are small, crystallized discs vibrating at an ultrasonic frequency. A transducer should last 10,000 hours, or about 3 years under nominal conditions. If the water pan is allowed to build up with mineral scale, organic growth, or other contaminants from your environment, this can stress your transducers and severely shorten their lifespan. If the float is not clean and clear, this will inhibit it from moving up and down freely and will keep your mist-free unit from working properly and can even damage it. Some applications may find they need to clean the inside of the unit to keep the water pan clean and clear. To do this, simply shop vac the water out of the water pan. Use a diluted alcohol or bleach solution and wipe the inside of the water pan out. Do not use a chemical cleaner, as the finishing agents and chemical cleaners can harm the crystallized transducers. You simply want to disinfect the water pan. You also do not want to scratch or scrape the transducers themselves. You can let the bleach or alcohol solution set on them for a short time and flush them out with fresh water. After cleaning the unit, prime the transducers with about an inch of water, just like at startup. You can think of the water pan like in an aquarium. If you clean it regularly, it will be fast and easy to manage. If you wait until it is a murky, dirty mess, it will be that much harder to fully clean, and damage may already be done. It is also necessary to ensure the float switch inside the water pan can move up and down properly. This float is a dual stage float that both communicates with the solenoid in order to keep the mist-free filled with the prime amount of water, and will also shut down the humidifier in the event of low water. You may remove the styrofoam stopper from the shaft in order to clean both thoroughly. However, be sure to note that there are two small magnetic discs on the bottom of the styrofoam stopper. You must ensure the magnetic discs are in the bottom position when reassembling your float. Also, be sure to secure the metal float house back in place. The float house ensures a stable water level for the float to measure.
The last best practice we want to talk about is seasonal shutdown. A humidifier should never be kept with water inside not being used for an extended amount of time. Stagnant water can create an organic growth or buildup that can damage the transducers or clog the solenoid. Anytime a humidifier is not going to be used for an extended amount of time, you're going to want to empty the water with a shop vac like we discussed before, and wipe the unit down with a diluted alcohol or bleach to sterilize any organic growth in there. You can then safely store the humidifier off. When you're ready to use your humidifier again next season, treat it like a new humidifier and refer to the startup guide at the beginning of this video to bring it back online. We would like to take this opportunity to go over some troubleshooting tips for your Mist-Free Series humidifier. Any troubleshooting done in the Mist-Free Series will require you to remove the fan cover to get at the interface plate beneath. You can remove the fan cover by removing the 6 thumb screws, 3 on each side, and removing the fan cover itself. Note the 3-foot cord between the Humidistat and the terminal block. Be sure not to pull or strain on this cord. The 3 main tools you'll need to troubleshoot a unit is a multimeter or voltmeter, the wiring diagram located on the stainless steel vertical, and the serial number located on the center of the vertical. Humidifirst will not be able to assist in troubleshooting without the unit's serial number. The 3 most common problems encountered are the humidistat is not reading correctly, the unit is not producing humidity or mist, or the unit is overflowing with too much water. Let's look at them one at a time. A common troubleshooting scenario can be the humidistat not reading correctly. Your humidifier will not be able to maintain your desired humidity level if the humidistat cannot read correctly. In this example, we have a relative humidity of 67.4%, but the humidistat is reading 86.5%. The most common cause of this is user error, or calibrating the humidistat incorrectly. The humidistat should always be calibrated to 0%. To calibrate a humidistat, hold the dot button down for 3 seconds, and you will see SELCALT, that's Select Calibrate Temperature. If you hit up, it'll say Select Calibrate Humidity. Press the dot button. Right now it is set at 15%. This means the humidistat will read 15% above its measure. Again, a humidistat should always be calibrated to 0%. Once calibrated, press the power button 3 times to reset the humidistat. Turning the humidistat back on, you will see our reading of 68.3 and 71.5, much closer. Note that 2 relative humidity sensors will almost always read slightly off. This is just the nature of relative humidity sensors. If you ever see an Error 1 message in your humidity reading, this means the actual humidity sensing chip in the humidistat is failed damaged, corroded, and is no longer useful. You can remove the small set screw at the bottom of the humidistat to remove the faceplate. You will see the humidity sensor chip in the bottom of the humidistat. This is meant to be replaceable for this scenario. Note, relative humidity is relative to temperature. If your humidistat is located where a heating vent or air conditioning vent can blow directly at it, this will affect your measurement. Be sure your mist-free is located in a position where it can take an accurate measurement of the space and room you want to maintain. The most common troubleshooting scenario is the unit's transducers not operating, or the unit does not produce mist vapor. If you hear your humidifier running, but the relative humidity in your space is not increasing, this may mean your transducers are not operating. The easiest way to verify the transducers is to visually inspect the water pan while the unit is operating. Turn your unit off and remove the fan cover and chute to get at the water pan. Restart the unit and make sure the set point on your humidistat is higher than the relative humidity reading. We will now show you operating transducers. Each transducer should have a 2 to 3 inch fountain or finger of water off of it, and the mist would roll off that fountain. All transducers should be operating at the same time in a uniform pattern. Another scenario that can keep the transducers from operating is low water or not enough water supplied to the humidifier. Note the humidistat is on and calling for humidity, but the transducers are not operating. This is because there's not enough water in the water pan for them to operate safely. Inside the small metal housing is a 2-stage float. When the float reaches a first mark, it communicates to the solenoid to refill with water. If the float hits a secondary low mark, it cuts power to the transducers so that they cannot operate without the proper amount of water on them. Activating the water line will show the humidifier refilling with water. Once the humidifier reaches the necessary amount of water, it will allow the transducers to operate again. If the water was to be shut off or interrupted to the unit would shut down completely. In a scenario where you have an undersized RO reserve tank or undersized water treatment system that can't provide water to the humidifier fast enough, you can create a scenario where water trickles into the unit. This will sometimes allow the float to be in the position to allow the transducers to run, and sometimes not. And the unit can go back and forth and chatter between operating and not operating. Or the float can reach just the level to allow the transducers to operate, but not allow it to fill up to its prime level. These scenarios can actually stress and damage transducers. You always want to make sure you have a full and proper water supply to your humidifier. And again, once the unit fills up to the proper level and the float reaches its top position, the transducers will turn back on. Another common troubleshooting scenario is a blown fuse. Humidifirst suggests verifying if a fuse is good or bad by reading the voltage across it. Sometimes a fuse can blow and still allow continuity, so just reading continuity will fool you. Let's take a minute to look at the transformer and talk about the power structure inside the mist-free system. On the transformer, you will see a primary side with a black and white wire, and a secondary side with an orange, red, and blue wire. The primary side of the transformer is the incoming power, in this case 120 VAC, although 230 and 480 are available. The black wire is the incoming 120, and the white wire is the neutral. You can verify this with a voltmeter or multimeter set on AC. Simply take your prongs to take a reading across the black and white, and you will see your 120 VAC. On the secondary side of the transformer, you must use the secondary neutral to get an accurate reading. In this case, we'll take a 24 volt reading on the red wire and a 48 volt reading on a blue wire. Taking a reading on the secondary side of the transformer against ground will not give you accurate readings. We'll show you this now when the transformer is drawing. As you can see, when the transformer is drawing, you cannot get an accurate volt reading to ground. When reading the secondary side of the transformer, always use the secondary neutral to take your power readings. The same rules apply when looking at the fuse block. Black is 120 on the primary side of the transformer. Blue is 48 volts on the secondary side of the transformer. And red is 24 volts on the secondary side of the transformer. To verify a fuse is good, use your corresponding neutrals on the transformer as discussed. To check the 120 volts, we will use one prong on the transformer's neutral on the primary side. Check the incoming power of the fuse is 120. Check the outgoing power of the fuse matches 120. On F2, the incoming power is 120. The outgoing power is 120. When checking your secondary fuses, be sure you're using the secondary or orange tap on the transformer to get an accurate reading. In this case, we have one prong on the secondary neutral and can check the 48 volts coming in, the 48 volts going out, and on the 24 volt fuse we can see the 24 volts coming in and the 24 volts coming out. In the scenario of a blown fuse, we would see the 48 volts coming in but no voltage coming out. This would tell you that that fuse is blown. Check the wiring diagram attached to your unit for all fuse ratings. These fuse ratings must be followed for your system to work correctly and be protected safely. The mist-free system also utilizes two surge arresters in conjunction with its fuses. There is a surge arrestor for the 48 volts located across terminals 1 and 2, and there's a surge arrestor for the 24 volts located across terminals 21 and 22. A surge arrestor protects the circuit in the event of a power surge. If too much voltage comes through the circuit, the surge arrestor will arrest and create a short, blowing the corresponding fuse. If you have a blown fuse that you replace with a new fuse, and this new fuse immediately blows, you're going to want to check your surge arresters, as that is likely the culprit. To check a surge arrestor, it is best to remove it from the terminal block. To remove it from the terminal block, you will notice the small slits just above it. Using a small tech screwdriver, insert it into the block, and you can remove each side of the surge arrestor. Once you have the surge arrestor removed, we can check it. To check a surge arrestor, you want to check for continuity across it. A good surge arrestor will not have continuity across it. When a surge arrestor is blown, it creates a short or continuity across it to blow the corresponding fuse. If you take your voltmeter or multimeter and set it on continuity, you can place one prong on each side of the surge arrestor. A good surge arrestor will not have continuity across it. Sometimes the simplest solution is the correct one. A loose wire can keep a relay from being energized and the system from working correctly. This can sometimes happen on a brand new system, as sitting on a truck during shipping can loosen electrical connections. When starting up a new system or troubleshooting a system not working correctly, it's a good idea to just check the tightness of each electrical connection, as all it takes is one small loose connection for the system to not work correctly. A failed or damaged component will also not allow your system to operate correctly. Looking at the mist freeze interface plate, you will see the fuse block, the R2 relay, the R4, the R1, the R3, and the terminal block to connect the wiring. The transducers are controlled by the R1 and R3 solid-state relay. When the transducers are operating, both these relays should be lit green. If your transducers are not operating, also check these relays to see if they are lit. If one of these is not lit, you can follow your wiring diagram or contact Humidifirst to investigate why. The final test for transducers not operating is to verify the transducers themselves are receiving 48 volts AC. If your humidistat is calling for humidity, you verified your transformer power is good, your fuses are good, and the solid-state relays are both lit, your transducers should be receiving 48 volts AC. You can verify this on terminals 1 and 2 and 3 and 4. Terminals 1 and 2 power row A, terminals 3 and 4 power row B. The small openings in the middle of the terminal blocks are used to make contact with the circuit. Having your voltmeter set on AC, we can take a reading at terminal 1 and 2 and see our 48 volts. We can take a reading at 3 and 4 and see our 48 volts for row B. If these terminals are powered by 48 volts and your transducers are still not operating, the transducers themselves may be failed.
Let's go over the process of changing the transducers now. First, always make sure the unit is unplugged and the water line disconnected when performing any maintenance. Remove the fan cover as discussed earlier, but in this case it's best to remove the humidistat line completely from the mist free. This will make it easier to move around and work with when changing the transducers. Simply take a Tek screwdriver and insert it in the slot above the wire to release the clamp and pull the wire out. You want to do this for all 4 wires that connect to the humidistat. After removing the wiring, you can set the fan cover aside to protect it. You're then going to want to remove the water from the water pan completely. A shop vac is the easiest way to perform this process. You can then carefully tip the mist-free vertical on its side. Always tip the unit away from the side with the water connection and electrical cord. You You can then use an electric driver to remove the 5 1/4-inch bolts on the front and back of the mist-freeze wheelbase. Note each of these 1/4-inch bolts will have a lock washer with it. Be sure to save and reuse both. You can then simply remove the unit's wheelbase. This will allow you access to the transducer bed. You can see each transducer has a corresponding circuit board that drives it. There will be a blue and yellow wire in between the circuit board and transducer. There is also a daisy chain harness that connects and powers all the circuit boards of the unit. You will need a number 6 socket to remove the transducer and circuit board. If you're using an electric driver, have it set at about torque 4. First, remove the 2 daisy chain wires from the circuit board, and then you can remove the transducer and circuit board. Simply unscrew the 2 screws that hold the transducer on, and the 2 screws that hold the circuit board on. You can then remove the circuit board and transducer completely. Be sure to save and reuse the plastic O-ring and red grommet seal where the transducer mounts. The transducer will not be sealed to the water pan without this and will cause a water leak and will damage the circuit boards. You always want to replace both the transducer and the circuit board when changing a unit's transducers. Take your new circuit board and transducer and simply install them where you removed your old ones. Again, make sure your plastic O-ring is in place and the transducer sits flat and flush to be watertight. Again, have your electric driver set at about torque 4 when retightening your number 6 lock nuts. Over-tightening these lock nuts down can break the metal studs that the lock nuts attach to, or over-tighten the transducer, breaking its seal and causing it to leak. Do not over-tighten the transducer when reassembling. After the circuit board and transducer are reinstalled, make sure you plug the transducer into its circuit board per instruction. Yellow on pin 1 and blue on pin 2. Also make sure you reattach your daisy chain lines per instruction. White on number 1, black on number 2. After reinstalling all your transducers, double check all your electrical connections are tight and secure before reassembling the mist-free. You can now reattach your wheelbase. Make sure you line up the holes, 2 in the front and 3 in the back when replacing the wheelbase. Make sure the 1/4-inch lock washers remain on the bolts to ensure the wheelbase stays secure on the stainless steel vertical. You can then tip the unit back in its upright position. Make sure to drop the unit slowly and carefully as not to damage it or loosen electrical connections. At this point, reattach your Humidistat wires per the wiring diagram. The 4 wires will be replaced in order white, red, green, black. To reinstall a wire, simply use your same tech screwdriver you used to remove it and press the ferruled end into the clamp terminal. The clamp terminal will automatically secure the wire. After all wires are in place, give them a small tug test to make sure they are securely held. Your unit is now ready to run with its new transducers.
This concludes the summary of the Mist-Free Series Ultrasonic Humidifier. For further assistance, troubleshooting, or information, contact Humidifirst at 561-752-1936, or you can email us at humidifirst@humidifirst.com. If you're troubleshooting a system you already own, be sure you have the serial number recorded for us. Be at the unit with a voltmeter for phone support. Thank you for watching.